Aconcagua was really part of this larger vision, trying to expand observational networks to the highest reaches of our planet.
So there aren't very many weather stations worldwide, full stop actually, considering how important the weather is to our everyday lives, you know, to the flights we take, the clothes that we wear when we step out the door, the danger that comes from extreme weather, whether it's flooding, high winds, high temperatures. There's only in the order of a couple of tens of thousands of weather stations worldwide distributed across that enormous Earth's surface area. When it comes to high altitude, that number falls off precipitously.
That's a big motivation for this project, is to install a network of weather stations from base camp, Plaza de Mulas, all the way up to just below the summit.
Working at the elevations that we did on Aconcagua, as high as 22,800 feet, requires quite a bit of physical preparation. It's important to be able to work when we get there to install the sensors, and then even more important than that is to have the ability to recover. Pluvio 2 and the Parzival go on these pipes, you know, they mount on the pipes. And it's not like you can back up a concrete truck and pour a slab up in these areas. And so, but even just a minute, you know, at that altitude, if you're digging hard, takes a huge toll on you.
But what happened to you pacing yourself?
The precipitation station that we installed at Camp 2 at about 18,200 feet or so. If I'm not mistaken, it's the second highest precipitation monitoring station in the world.
From a research standpoint, one of the really exciting characteristics of especially the Pluvio weighing precipitation gauge that you see back here is its high resolution. We get 1 minute measurements of precipitation accumulation. And in mountain regions, I mean, we're lucky to have just a handful of stations that measure precipitation at daily intervals, let alone, you know, maybe a few here and there that might have hourly measurements of precipitation. But again, that's not with the same quality that you see here with an AlterShield, double AlterShield to minimize wind effects, or with the accuracy that the Pluvio weighing precipitation gauge provides. All right, Pluvio is working.
I wish I could see more Pluvios out there in networks, because the quality of precipitation observations, especially in some of these mountain locations, is not as, they're not as good as they can be. So the Pluvio 2 is incredibly important, and that's been just the workhorse sensor that I have used to measure precipitation. The other kind of workhorse instrument just that I've incorporated in nearly all of my stations is the Parzival 2.
And one of the most important variables that we're excited to measure with this instrument is how much rain is actually falling now at this elevation. We've had no observations to do that in the past. Whatever type of precipitation falls through that laser beam, the sensor knows exactly how much of the laser beam is impacted, is blocked, and for how long. And using that information from the particle size and the fall speed, we can get a pretty accurate determination of the intensity of the precipitation and the type, whether it's rain or snow or graupel or even hail.
Do you have a look at solar
Are you looking at the minute data?
Yeah.
Yeah, nice.
1 minute solar radiation data. It's extraordinary. It's perfect, almost perfect profile. Maybe some.
The CNR4 from Kippenzonen is installed on our highest station at the summit. This is just right at 22,800 feet, and so it's the highest station outside of the Himalaya. Until we had these measurements, we weren't able to really quantify exactly how high. And it turns out that on Everest, we started to see values that were greater than we would expect at the top of the atmosphere. right? Okay, so is this just an isolated phenomenon here in the Himalaya? Well, as soon as we set up the stations on Aconcagua, we began to see similar values that were at times higher than what we know is the maximum at the top of the atmosphere. And it turns out that these interactions between snow and ice on the ground when it's present and also cloud cover can result in some extreme values of irradiance. We call these over irradiance events. And so this is only something that you can really begin to gain a better appreciation of by having multiple measurements at sites at different places around the world. The SHM31 laser snow depth sensor, which I've only started using relatively recently, and we were able to take one to Aconcagua too. And it is a game changer as well. I mean, the millimeter scale accuracy that we see with it and just high reliability is pretty phenomenal. That's going to be an essential component of all my future stations. I mean, these stations that we set up on Aconcagua, nobody's going back until probably December, the earliest. And so that's 9-10 months. But if something stops working, it's impossible to send somebody out. And that's one of the fundamental challenges on Aconcagua. And that's why we have to have sensors that are durable, that can survive these extremes. And we have confidence in the OTT Hydromet products because we've used them in other mountains around the world. And they have performed very well there.